Good afternoon, all students in the house. We want to look at this question. It's under integral calculus. So we have to find the definite integral of 1 over 1 plus exponential x dx. Now, when you come across this question in any exams, you need to know the principles, in solving integral calculus, generally calculus, because calculus does not really relate with, normal arithmetic, calculations. So we need to abide by some rules and guidelines for us to get the accurate answer here. Now, the first thing we are going to do here, the first step we are going to, perform here is to apply, the substitution method in solving our, integral calculus. So at this junction now, we can say that let u equals to 1 plus exponential x. So if u equals to 1 plus exponential x, now let us, differentiate u with respect with x. We can say that the x equals to exponential x, because if we differentiate 1 is equal to 0. When you differentiate 1 equals to 0. So when you differentiate exponential x, the answer equals to exponential x. So differentiation of exponential x will yield exponential x. So that is our du dx. That is the u dx. Now from this we can find the x. So we can say that, okay, we can say du equals to exponential x dx. Now what is now the x? We can say that the x equals to du divided by exponential x. So this is our dx now. So from this we can, input the whatever you get here into this particular equation. You get it now. So instead of writing the x, we can write what? Du over the x. So while writing now, we have exponential. So we have the integral. This is the exponential, and this is the u. So we have integral. We have 1 over 1 plus exponential x. Then our dx is du over exponential x. That's just it. But the limit we have under this integral needs to be changed, because we now want to differentiate. We are now relating with respect with u now. So which means our limit values here must be related with what? With u. Don't forget that. So for us to know this upper and lower limit, we need to apply this formula from u equals to 1 plus exponential x. You see now. So when the upper limit now, when x equals to 1, which is the upper limit, we can say let me call u2 my upper limit, and equals to 1 plus exponential. You know that exponential is called exponential is 1 is equal to exponential. Then when x equals to let me call it 0, that is the lower limit. I can say that u1 equals to be 1 plus exponential 0. So exponential 0 is the same thing as what? 1, because any number raised by 0 equals to 1. That is the rule guiding it. So which means our u1 equals to 2 here. You get it now. So if you now want to rewrite now, we can say that our upper limit here and lower limit here will now be what? It will now be 1 plus e and what? And 2. So we now have, that is 1 plus e, and lower limit is equal to 2. So we have 1 over, that's 1 plus exponential x, then multiply by, that is 1 over exponential x du. Can you see now? I've already splitted it. I splitted it. So here we know that u equals to 1 plus exponential x, and then exponential x equals to, that is u minus 1. You get it now. So we are going somewhere. So we have, so integral 1 plus e and 2. So here now we now have, so you know that instead of writing 1 plus exponential x, we have 1 over u. So we are going to have 1 over u, then multiply by, so instead of having 1 over exponential x, we have, that's 1 over u minus 1. So here we have times 1 over u minus 1, then du. Can you see now? Du. So we move further, that's 1 plus exponential, and then, with lower limit of 2, we now have 1. So when you multiply these two factors, we have 1 divided by, that is u into bracket u minus 1. So at this junction now, we are going to solve, with respect with partial fraction. So here we can see that that's okay. For further we can have that's 1 over u into u minus 1. Then it can be equals to a over u plus b over u minus 1. You see now. So we are going to find the LCM. What's our LCM here? So we factor out the LCM. LCM remains u into u minus 1. Don't forget that our target is to find the value of a and b. So u goes in there, we have a into bracket u minus 1, then plus that is a bu, then equals to 1. You see now, equals to 1. Equals to 1 a. So don't forget, we're going to have 1 a at this junction. So that is 1 over u, minus 1. Are you see now? So your whole concern is the numerators now. So we are going to focus on the numerators now, which means the denominator will be cancelled out. Then we focus on the numerator. So we now have 1 equals to, that is a into bracket u minus 1. And you see plus bu. Now let u equal to 0. Let's first find the factor of u. Let's find one of the factors. If u is equal to 0, we now have 1 equals to, that is a to bracket, that's 0 minus 1, yes, plus, so b times 0, everything here becomes 0. So we have 1 equals to, that's minus a. So what is our a? A is equal to minus 1. So what is now b? Now the next factor of u will now be u minus 1. Don't forget that from these factors we have here, there are two main factors here. We have u and u minus 1. So we are going to equate each factors to 0. So when we first equate u to 0, we arrive at this, which is a is equal to minus 1. When we now equate u minus 1 to 0, what will now be the result? U is equal to 1. Are you see now? So which means we have, from the equation, we now have 1 minus 1, 1 equals to, that's a into bracket, that is 1 minus 1 plus b. Can you see? B times 1 is b. 1 minus 1 is equal to 0. So everything here becomes 0. We now have b. So b is equal to what? B equals to 1. So we have already found the values of a and b. Values of a and b. So we continue. So we rewrite now, which means we now have exponential of 1 plus e, then with lower limit of 2. That'll be, so that initially we have a over u, right, plus b over u minus 1. So what is the value of, we now have 1 plus e exponential 2. So a is what? Value of a is minus 1. That's minus 1 over u, plus b is what? 1 over u minus 1. So we can rewrite as upper limit. So it can be also 1 over u minus 1 minus 1 over u. Yes, we can do it in this way. So when we now integrate these factors, integrate this factor becomes ln, that is u minus 1. Can you see? U minus 1 minus ln u. So with upper limit 1 plus e and what? And lower limit of 2. So when we now input the limits into the particular equation, we now have ln 1 plus e, you see now, minus 1, then minus ln 1 plus e. And you see, minus, now we have already sorted out for the first one. The second one is for 2. That's ln 2 minus 1. What is 2 minus 1? 2 minus 1 is 1. Then minus ln 2. So here we now have, so we have ln, so 1, we cancel out 1, then remaining ln e. Then minus ln 1 plus e. So ln 1 is equal to 0, which means the last one will now be, so don't forget that this minus we have here, we multiply through this particular internal factors. So we now have minus, that's minus 0 now. Can you see minus 0 and plus ln 2? So we now have ln e minus ln 1 plus e plus ln 2. So that is the final answer. That's the final answer. So thank you very much for listening to this. So you can look at it very well.